Hi, everyone. This is Jim Cahill from the Emerson Automation Experts blog. And today we have a podcast, part of the Enabling Storage Terminal Safety podcast series. And today we're going to talk about mitigating tank damage with floating roof monitoring. And I'm joined by Per Skoberg and Christopher Hoffman. And I guess to get started, why don't we start with you, Per? Could you give us a little bit, introduce yourself, tell us a little bit about what's your title and your education and background?
Yeah, sure. I'm a solution manager at Emerson, working with our tank gauging system. I studied industrial engineering and management at university and have a Master of Science in Management and Economics of Innovation. I've been with Emerson now for 6 years, just about, in a few different roles, but actually always working with our tank gauging business.
That's great. And Chris, could you tell us a little bit about yourself?
Absolutely, Jim. I've been working with Emerson for approximately 10 years now. I have a multitude of roles, just like Per. My current role is Business Development Manager, primarily focusing on Latin America for tank gauging. My background actually comes from more of a IT world rather than the industrial world. So I'm bringing that picture.
Okay, that's great. I guess let's start out for our listeners. Can you share a little history of floating roof monitoring technology and why it's important for, some of our customers with storage tanks?
Well, the existence of floating roof tank was more or less unknown to most people outside of the industry. That said, before Hurricane Harvey swept across the U.S. in 2017, causing a lot of damage, and that you heard a lot of media reports about the damages that occurred for several storage terminals and refineries. You had tank failures, product spills, and a lot of release of hydrocarbon vapors and volatile organic compounds, or VOCs, into the atmosphere. And since then, safety of oil storage and floating roof tanks especially has become a much more widely discussed topic. And according to the International Association of Oil and Gas Producers, the IOGP, the incident frequency of floating roof tanks per year is 1 in 625 tanks will have liquid spilled onto the floating roof. 1 in 900 floating roofs will actually sink into the product in the tank. 1 in 8,300 tanks will develop a full surface fire, which is the extreme case.
And an interesting thing here, you might say, is that these incidents are actually, they're considered when they happen to be sort of one-offs or just, fluke accidents. But instead of, if you were to consider them as predictable events, it would be possible to prevent and mitigate this in a whole different way. And that's why it should be made a part of the systemic safety work to monitor the roofs. And that's where we now have an option to use automatic monitoring in order to be able to see when an issue is first arising. Previously, if you compare, then a tank could fail suddenly without notice, but now you would have a means to continuously monitor the status of the roof and to get early notice that something is amiss here and you should take action.
Yeah, it sounds like monitoring from a safety perspective is critical. Chris, what are some common issues you see in storage tanks without floating roofs, I guess some of the fixed tank roof? What are the disadvantages of those types of tanks?
Well, before the invention of floating roof storage tanks, these tanks were often without any cover or top at all. So it was leaving the product exposed to the elements, and that, of course, comes with numerous disadvantages. You have evaporation of the product, so product loss. You have increased risk of ignition, since there's no protection. And you also had the risk of product contamination. So the roof storage tank can be the easiest, the best analogy I find is to compare it to a swimming pool and the swimming pool cover, because they basically do a lot of the same things. And the main reasons you started using floating roofs in the first place were to reduce evaporation from the stored product, which in turn has several benefits. You reduce the risk of igniting the volatile vapors. You reduce the significant impact on the economics on your operation. You reduce emissions released into the atmosphere. This is a big talking point that's becoming more and more brought up, because stricter and stricter regulations for product emissions allowed into the atmosphere, and you need to regulate them. You need to keep them under control as much as you can. And lastly, you protect the product from contamination like precipitation and debris. And depending on where you are in the world, we're talking about rain or snow or sand or whatever that you want to keep out of your tanks.
Well, that sounds like a lot of good reasons for floating roofs and why you see them more widely in use today. Per, what are some important considerations or advantages and disadvantages when investing in floating roof tank storage?
Well, yes, there are some disadvantages, as you said, and mainly it's because the floating roof it's like this really big moving part, which then has wear and tear and requires maintenance. Of course, any failure of that roof, as Christopher mentioned, can have quite severe impacts. In worst case, a fire or otherwise injuries or tank downtime or a number of different or other issues. To add on top of that, I mean, there are both internal and external floating roof tanks, and the external tanks, they are exposed to the elements, which of course can't be controlled. And that's what we saw in the case of Hurricane Harvey, that caused a lot of problems. But then, due to all of this, it's practiced that, of course, the roof should be inspected regularly, but that requires a lot of effort, and it's not always that those such inspections are performed as they should be, and that could be for a number of reasons. First of all, it's a safety hazard for operators to climb down to the tank and climb down to the actual roof of the tank. And there's typically a permit process involved there that you need to go through to gain access to the tank, and that could be cumbersome. And then the operating parameters might simply not be right for inspection when the need arises. For example, if the tank is in service, you would prefer to enter the roof when the tank is full and the roof is at the top position. But that of course, isn't always the case. And it may also be that management simply doesn't understand the likelihood or the consequences of an incident occurring, or there might not be enough operators to prioritize this particular job against all of the other things that you need to do in your tank farm.
Yeah, it sounds like there's no perfect solution on the type of tanks there. So for these floating roof tanks, what are some signs of what a damaged floating roof looks like, Chris? And how easy is it to detect this damage?
Well, there are numerous failure modes and types of damage that can occur. Some are easier to spot than others. An easy indication that there's an issue is you can see the tank product on the top of the tank roof where it's not supposed to be. That's one of the easy indications. But this could indicate roof leakage, which could in the end lead to the roof sinking completely. Another sign is that the roof is tilting. It's not floating level. It should always be as level as possible on the product and follow the product it's floating on. However, if you're standing there, these are big structures. Spotting a tilting roof just by visual inspection alone can be difficult because it looks level when you're up close to it. If you have a tilting roof, that could in turn indicate numerous different problems. You could have leaking roof pontoons, enabling the roof to be easy to spot, sometimes not. You can have a leaking center deck, which is the inner portion of the roof, where you can have a puncture. Have leaking roof rim seals, the seals around the roof towards the tank walls. You could also have buckling of the tank shell or rough spots where the roof seal binds to the tank shell when it moves up and down. So all of these are different indicators of different problems, but all of them can have severe effects.
And there are also a number of other failure modes. For example, the roof might sink or start tilting from heavy rain or snow or even sand from sandstorms in that part of the world. If that happens, that typically often is connected to the roof drain being clogged or underdimensioned, or maybe the valve just happened to be closed, so it hasn't let the water out as it should. Another thing that can cause tilt actually is strong winds, and of course, if that happens in combination with rain or snow, that could lead to the roof tilting rather severely. And then also it may be that the rolling ladder that normally you would use to gain access to the roof, that can get stuck and prevent the roof from floating freely and following the liquid level up and down as it falls or rises.
And regardless of the cause, an incident involving a floating roof impacts operations to some extent and requires a number of measures to be taken before the situation is back to normal. The specific measures needed will, of course, depend on the type of the incident, but effects of a floating roof failure can be a lot of different things. For example, you need to take the tank out of service. You need to clean up spills, worst case. If you have an incident, you have incident reporting to the proper authorities, which in turn can have consequences on their own. You need to monitor the air quality for any pollution as a result from evaporating product. You need to clean the product if you have product contamination from any water or any dirt or any, for example, in case of a fire, you have to put it out using foam or anything like that. You need to clean up everything. Then you have the repair costs of the tank and or the floating roof, which is no small task. You have costs and effects related to the emergency responder or fire brigade actions taken. And of course, you have interruption to your normal production and your normal operations. You can suffer, in case of an accident, you suffer damage in the public perception, the public eye, and your reputation from shelter-in-place orders and similar. And all of these consequences aside, it's not even considering the potentially disastrous effects of a full. So all of these are just the minor effects of a tank roof failure. But certainly all of these effects have a significant financial impact as well as putting the well-being of your employees at risk. So it's definitely not a problem to be ignored.
Indeed. And I mean, so the standard way to reduce the risk of incidents then would be to routinely and thoroughly inspect the roof. And that would include maybe climbing down to the roof, opening the manways into the pontoon compartments to inspect them on the inside, to inspect the roof legs and vacuum breakers and ensure that the rolling ladder is functioning properly, and checking or testing the parts of the seal that you can reach, and checking for corrosions and many other tasks. So it's an extensive job to be carry out these inspections. And you need to do it regularly, of course, according to whatever safety guidelines and directives you have in place. But unfortunately, as we mentioned earlier, it's not always the case that these are carried out as they should be.
And not performing inspections routinely will cause problems at a later stage. So when inspections are not carried out, you have less critical faults that could have been repaired, not discovered. And as time passes, these could escalate into more serious events. So in the end, this leads to operators being caught off guard by a sudden emergency, like Per talked about in the beginning, instead of having solved the issue by repair as part of routine maintenance. We mean that it's not a sudden occurrence. These all can be, or many of these failure modes can be detected early on. It's actually, in fact, rare for serious incidents to happen suddenly out of the blue without any warning signs that could have been discovered earlier. And using automation technology to continuously monitor the behavior of the floating roof then becomes a way to predict when a tank needs maintenance. So it's a way to improve routine where it's needed the most.
Well, I think you've really talked about a lot of the issues that can come up, both minor and major and routine maintenance and everything. And let's drill in a little bit about the automation technology. So Per, how has the Emerson team worked to help solve these problems?
Well, I would say that adding automatic monitoring to the floating roof is a reliable way to be able to predict and mitigate roof failures. Using radar level gauges, this can be done, in fact, without making any modifications to the tank. And then combined with our TankMaster software, which you use in the control room, you get an overview of the status of all your floating roofs. And then you can also get the history of roof movements, which can then be used to create a baseline for how the roof of each specific tank should be moving or is normally moving during operation. And then from that baseline, you can set up alarms to quickly identify abnormal behavior before any kind of serious incident would occur. And we use radar gauges since really it's the standard instrument, you can even say, for level measurement in bulk storage tanks. And it's a proven technology. It's been used for decades in terminals and tank farms all over the world, and it's very suitable for this application as well.
Depending on the tank type and existing conditions, the solution can be implemented in several ways. But the basic principle of operation is the same for all of these. You have 3 or more, you can have up to 6 level gauges are installed to monitor the position on the floating roof. So it's measuring to the roof, and then it's measuring these values and comparing them against each other and against a primary level device to detect any anomalies such as roof tilting or sinking. So it's basically calculating the difference between the different level points. You can also add drain sump monitoring, for example, in combination with this. So you can use a level switch to detect a clogged or a closed drain, like Per mentioned before. And in addition to this extra device, you can also add hydrocarbon detectors to integrate into this monitoring software to detect any product leaks onto the tank roof.
So Per, can you give our listeners, a picture of the process of what it takes to set up these monitoring solutions?
Yeah, sure. I mean, there are 2 basic principles here. There's shell-mounted installation and there's roof-mounted installation. And in the case of shell-mounted, you would use a non-contacting radar, specifically either the Rosemount 5408C radar level gauge. And you would use, as Christopher said, minimum 3 of these, and they are installed at equal distances from each other on the tank wall at the very top of the tank. Directly below each radar, you place reflector plates to enable measurements without disturbances, even if the surface is uneven or if there are objects protruding from the roof or if there happens to be a heavy snowfall or anything like that. And then the tilt of the roof is tracked simply by comparing the distance from each gauge down to the floating roof or the reflector. That's the non-contacting solution. It's very accurate, it's very reliable. It can be retrofitted to existing tanks without taking the tanks out of operation. If you add the ordinary level measurement as a reference to the system, you can also monitor the buoyancy of the roof to see if it's floating higher or lower than it normally does.
And then we have the second type of installation, which is the roof-mounted installation using a guided wave rate gauge. So this is an alternative solution where you can use up to 6 guided wave radar transmitters, between 3 and 6, directly on the floating roof itself. You're using a rigid probe penetrating through the roof and into the liquid. And then you track the roof tilt by comparing the distance from the floating roof down to the product surface. And you will also track the roof buoyancy with this solution. So it's almost working in an inverted way from the non-contacting version, but the result is the same. And one major advantage you get with this on-roof configuration is that it's 100% wireless. It's a battery-powered solution where we use the Rosemount 3308 wireless guided wave radar, so no strings at all attached.
So I can visualize both ways. One, you're kind of fixing it on the tank itself, measuring down to the where the roof position is, non-contacting radar. And the other, you're actually mounting the instruments on the roof itself into the liquid down to compare between those. That makes sense. So Per, what does a fully automated approach look like?
Well, so beyond the level gauges on the tank, the data can be transmitted either wired or through wireless communication to the control room, where an operator can monitor the roof status. And you can also add more instruments to the tank for more extensive monitoring, as we mentioned a bit earlier, I think. For example, you can monitor the drain sump to make sure it isn't clogged or it's not overflowing, or you could monitor for water gathering on the roof itself. For that, we would use a Rosemount 2160 wireless. But you could also detect if there are hydrocarbons that are accumulating or pooling on the roof itself by using a Rosemount 702 wireless transmitter and with a liquid hydrocarbon detection attached to that. So there's really much useful data that you could gather from up there on the tank. And then with the software in the control room, you would get automatic alarms for roof tilt, buoyancy, roof sticking, and as well then as for drain sump blockage or hydrocarbon detection.
Yeah, that sounds like you have a really good picture remotely there of what's going on with the tank. So I guess, Chris, what are some common concerns about adapting to an automated approach as opposed to what's historically been done through a manual approach?
Well, if the question is, should I go for a roof-mounted installation with guided wave radar, or should I go for the shell-mounted version using non-contacting radar? It's not really possible to give any general recommendations like that because all tanks are different. They have different characteristics. I mean, it's like when you go to a terminal, every tank has its own personality almost. It all depends on what suits best for each particular tank. It's going to depend on things like what kind of tank openings and nozzles are available, roof, what kind of infrastructure is already in place, such as when it comes to power and communication cabling, or if you have any existing wireless networks already on the site, and also what kind of instrumentation you already have installed on the tank itself. So there's no really hard rules. There's one recommendation for best practice is if you're using an internal roof tank. There are external and internal floating roof tanks. So if you're using the internal floating roof tank, it needs a shell-mounted installation using non-contacted radar.
I think the beauty of the
installation using non-contacted radar.
I think the beauty of the system that we have is that you're entirely free to combine the two technologies. You can have a roof-mounted monitoring on some of the tanks and then use shell-mounted on some of the other ones. And you can have wireless data transfer for one tank and wired communication to all the others. And in the end, it's all integrated into the same system. So there's a large degree of freedom there in regards of installation.
So Chris, let me ask, how would you sum up performance gains by using these automatic floating roof monitoring solutions?
Well, in short, installing automatic floating roof monitoring it's all about increasing reliability and safety by moving from being reactive to being proactive. Whereas previously floating roofs could suddenly fail without notice, now if you automate it, you can have means to continuously monitor the health behaving as normal. You can send personnel out to properly inspect it when needed. Based on the findings, you will be able to schedule and plan repairs and maintenance. This is opposed to discovering a problem only after an incident has occurred and then having to deal with all of the consequences we mentioned before, like fire prevention measures, cleaning up, reporting emissions, regulation violations, potentially having to take the tank out of service, and not to mention damage to people or property and many other.
And in addition to this, there's just the fact that there's less need to send personnel out into the field, into the hazardous area for routine inspection rounds, potentially in bad or even dangerous weather conditions.
Well, it sounds like this automatic monitoring can provide a lot of information and help people better understand when there's a problem early and be able to go deal with it for safer and more reliable operations for the tank farms. So where can our listeners go to learn more, and how, if they have specific questions coming out of this podcast, how can they get a hold of y'all?
For more information, you go to our webpage for tank caging, which is located at emerson.com/Rosemount-tank caging. And you can also visit our other website for the overall terminal safety initiative, which is emerson.com/terminal-safety. When it comes to contact, you can always contact us on LinkedIn.
I know you guys are active in LinkedIn, so that's a great way to get a hold of you. All right. Well, I know I've learned a tremendous amount about the different types of tanks and the different types of ways that we can make sure things are operating. I want to thank you both, Per and Chris, for joining us today and sharing your knowledge and experience with our listeners. Thank you very much.
Thank you.
Yes.
Thank you for having us.